Alright, so I figured for this video we would take a quick look at the isolation pattern, um, and we're going to be reusing the app we made last time when we looked at um, window customization. Start by looking at the documentation. Isolation pattern. The isolation pattern is a way to intercept and modify Tauri API messages sent by the frontend before they get to Tauri core. All with the JavaScript. The secure JavaScript code that is injected by the isolation pattern is referred to as the isolation application. Okay. So why do we do it? Well, the isolation pattern provides a mechanism for developers to help protect their application from unwanted or malicious front-end calls to Tauri core. The need for the isolation pattern rose out of threats coming from untrusted content running on the front-end, a common case for applications with many dependencies. And the largest threat model described above that the isolation pattern was designed in mind with was development threats. Not only do many front-end build time tools consist of many dozens or hundreds of often deeply nested dependencies, but a complex application may also have a large number of also often deeply nested dependencies that are bundled into the final output. So what this means is basically when you have an application where you have a front end running with JavaScript that's capable of making calls to Tauri. What if you have a dependency that decides to use the Tauri JS API to, say, copy or a file over to your computer like a virus and then execute it? You can do a lot of malicious stuff to the developer that way. You can do malicious stuff to an end user as well, but generally speaking, since you will have developed with the code first, you would have been given the virus first. It can happen for all your users as well, of course. It's just this is primarily a development threat, but it also does enhance security for your users as well. So when should you use it? Tauri highly recommends using the isolation pattern whenever it can be used, because the isolation pattern application intercepts all messages from the front end. It can always be used. Tauri also strongly suggests locking down your application whenever you use external Tauri APIs. As the developer, you can utilize the secure isolation pattern to try and verify IPC inputs and make sure that they are within the expected parameters. For example, you may want to check that a call to read or write a file is not trying to access a path outside your application expected location. Another example is making sure that Tauri API HTTP fetch call is only setting the origin header to what your application expects it to be. That said, it intercepts all messages from the front end, so it will even work with always-on APIs such as events. Since some events may cause your own Rust code to perform actions, the same sort of validation technique can be used with them. So, quick note on this. We do intercept all messages and such in order to, for example, verify things like the origin header. These are the sort of things that Tauri works on adding as much as possible to the allow lists. It's kind of like checking the scopes in your allow list to make sure that you don't allow too much. But thanks to the isolation pattern, you don't have to know how to develop your own allow list entries. You don't need to know how to add that at the Rust level. If you just know the JavaScript level, you can add an isolation application, and you can now manually yourself add the security to your application. So in a sense, the isolation pattern is largely related to when Tauri as an organization hasn't made the allow list secure enough for your purposes, you can use the isolation pattern to even further enhance security. I believe one of the main reasons why the brownfield pattern is used by default, which is essentially just don't make any verification in the JavaScript end, do everything in the Tauri end, is that we've worked hard on the scopes and limitations set on all API calls sufficiently already, where for most people adding the isolation pattern won't help. And again, isolation pattern is about enhancing security further than what Tauri already offers. We already offer, for example, the for the file system API. You already have all of these things you can check. You also have, let's see, scopes should be in here somewhere. Path, yeah, here. So here's the path allow list. I know we have, there we have fs allow list scope. So here you can set which scopes are allowed for the FS API if you use that. And the allow list applies to both the Rust end and the JS end. Some people believe it's only for the JavaScript end, but no, it's for both Rust and JavaScript. It's just that in the Rust end, people tend to start using commands and stuff that aren't part of the Tauri API. A user today used the standard library's command function, for example. And if you use the standard library in the Rust end, then that does not go through the allow list system. So if you're going to use Rust code, be aware that the allow list still applies. It's just that you're gonna have to use the Tauri APIs for it to apply. You can go around it in the Rust end, you can't go around it in the JavaScript end. How do we add it? The isolation pattern is all about injecting a secure application in between your frontend and Tauri core to intercept and modify incoming IPC messages. It does this by using the sandboxing feature of iframe to run the JavaScript securely along the main frontend application. Tauri enforces the isolation pattern while loading the page, forcing all IPC calls to Tauri core to instead be routed through the sandboxed isolation application first. Once the message is ready to be passed to Tauri core, it is encrypted using the browser's subtle crypto implementation and passed back to the main frontend application. Once there, it is directly passed to Tauri core, where it is then decrypted and read like normal. To ensure that someone cannot manually read the keys for the specific version of your application and use that to modify the message after being encrypted, new keys are generated each time your application is run. So basically, key is generated in the Rust end, key is generated or passed on to the isolation application. Your front-end code can't modify the sandboxed application however it wants to. So it sends a message to the isolation pattern application. That verifies that it's okay, sends it back in encrypted form, and then sends it forward to Tauri. And when you're using the isolation pattern, it will enforce that the message is passed back and forth in an encrypted manner requiring the key. So you can't just pass direct messages back and forth, they have to go through the application in order to receive the proper encryption. Approximate steps of an IPC message. To make it easier to follow, here's an ordered list of the approximate steps an IPC message will go through when being sent to Tauri core with the isolation pattern. So the Tauri IPC handler receives the message, the IPC handler sends it to the application, the application hook runs and potentially modifies the message is encrypted, the IPC handler receives it back, and the IPC handler sends it to the Tauri core, just like I just explained. Performance implications. Because the encryption of the message does occur, there are additional overhead costs compared to the brownfield pattern. Even if the secure isolation application doesn't do anything, aside from performance-sensitive applications Aside from performance-sensitive applications who likely have a carefully maintained and small set of dependencies to keep the performance adequate, most applications should not notice the runtime costs of encrypting and decrypting the IPC messages, as they are relatively small and AES GCM is relatively fast. If you're unfamiliar with the encryption pattern or the encryption used, all that is relevant in this context is that it's the only authenticated mode algorithm included in subtle crypto, and that you probably already use it every day under the hood with TLS. There's also a cryptographically secure key generated once each time the Tauri application is started. It is not generally noticeable if the system already has enough entropy to immediately return enough random numbers, which is extremely common for desktop environments. If running in a headless environment to perform some integration testing with WebDriver, then you may want to install some sort of entropy generating service such as HaveGED if your operating system does not have one included. And Linux since March of 2020 includes entropy generation using speculative execution. So limitations. There are a few limitations in the isolation pattern that arose out of platform inconsistencies. The most significant limitation is due to external files not loading correctly inside sandbox iframes on Windows. Because of this, we have implemented a simple script inlining step during build time that takes the content of scripts relative to the isolation pattern application and injects them in line. This means that typical bundling or simple including of files like this still works properly, but newer mechanisms such as ES modules will not successfully load. But when I show you the actual application in a little while, it's so simple. Like you don't need fancy bundlers for the isolation application. Recommendations. Because the point of isolation application is to protect against development threats, we highly recommend keeping your isolation application as simple as possible. Not only should you strive to keep dependencies minimal, but you should also consider keeping required build steps minimal. This would allow you to not need to worry about supply chain attacks against your isolation application on top of your front-end application. So now we get to actually creating the application. So let's follow it step by step and see if this makes sense. In this example, we will make a small hello world style isolation application and hook it into our imaginary existing Tauri application. It will do no verification of the messages passed through it, only print the contents to the WebView console. For the purposes of this example, let's imagine we are in the same directory as TauriConf.json. The existing Tauri application, that would mean that we are in this folder, is what they're saying. Let's imagine that we're in the same directory as TauriConf.json. The existing Tauri application has its dist dir to /dist, which we don't, but what we could make here is dist-isolation, or do we have it as /dist? We might actually, yeah, we do. It's just that we haven't built it yet. I do believe it's being built. Maybe it is. Maybe it is. Yeah, it is. Oh wait, it's TypeScript errors. Is that the document or if document? It's not possibly null though. Could I? I just wanted to get this to come compile. I'm not gonna go into that right now, so we'll just keep it like that. Because now we're not using it. TypeScript can be a little bit annoying at times, but it is what I recommend you use. So now we built it, now we have dist, and now we have dist isolation, just like they say. Now we're going to create an index.html file, and we're just going to copy paste this. Actually, we're going to press here. And we have the proper contents in there. Then we make index.js, paste that in there. Now all we need is to set up Tauri conf.json to enable the pattern. So now you should be able to find that. No, wait, that's an older version where we had that by default in there. There we go. So it's in Tauri pattern. Tauri, well, it's a pattern. And this is the default brown field, so we're gonna switch that to isolation. And options here /dist isolation. And that is all that we need. Oh, actually they had it right there. So that's good. I still prefer if we put these things further up, because now what happened was I read this, it told me to go to the configuration, I did that, and I mean, this is, it does link down to this part, but it would probably be better to just put that further up so that I do this as early on in the tutorial as possible, so that we're prepared for it. But let's run cargo Tauri dev. Now you shouldn't see anything visually different, but you should see something different when we check the console log. So let's go to the console, and here you can see hook object, notification, isolation, no, or is notification permission granted. As you can see, all of these hooks come from here now. And that really is it in terms of setting up the isolation pattern. If we now try to move this around, actually I can probably just keep this up while we're moving it around, if I just make it a little bit smaller. Okay, there we go. So if I try to move this around now, you can see that it creates a new hook message each time I try to move it. And that's because when the isolation pattern is used, I get a hook message. So let's check what the message is here. Start dragging. So if I go here and I do if payload.message.cmd is equal to, wait, actually we're gonna do message.data.cmd.type. God, that's a, I think that's going to be correct. Dragging, turn all. And now I believe we have to restart it in order to apply the isolation pattern update. So now, oh god, not great that it ends up on the wrong screen. Because what I just did was disable start dragging. Now I can't drag it to show you. Let's just do payload here. and I'll try to drag it, and no, I do have to rebuild the application. But at least that shows that I couldn't drag it now. So let's try some blocking some other action instead. Let's see, I can't use these buttons anymore because we commented that code out, but let's re-add that code. Now our buttons should work again, and yep, we're capable of doing all the good stuff. Open that. We can check that. Let's take maximize. So here we have toggle maximize is what we're running. If we go to our isolation pattern application, we can check for the payload, message, data, command type, toggle maximize. And if that's what happens, we return null. And if we now, we can still do that because now we rebuild it. Now if I try to press maximize, that doesn't work, but I can still minimize the application. So effectively what we've done now is the same type of fix that just setting the window allow list to allow maximize false, which is probably why we don't push the isolation pattern more than we do, because we've made a lot of updates to the allow list. It has basically all options you need. The isolation pattern only really becomes relevant when you have really high security demands, or when your allow list is starting to allow a bit too much. This way, you can essentially extend what you're capable of isolating by or disallowing from using the allow list. So as you can see, it's as simple as adding a second application with an index.html and an index.js. I would say you don't need to add TypeScript. You don't need a fancier HTML. In fact, you probably don't even want a fancier HTML. Just keep it at this level, honestly, and just keep adding entries in here. You don't have much reason to make it more advanced than this if you decide to use it. I generally use this level at least in all my applications, and honestly just have this level. They talk about performance implications of this pattern. The performance of this is only when you're doing API calls. The way I make Rust or Tauri applications is by keeping as much as possible in Rust. If you actually have something that's performance sensitive, keep it in Rust, and then this pattern doesn't really matter for you. This isolation pattern is only really doing anything if you're in the JavaScript end, and only if you have a lot of dependencies to take care of. I tend to keep my dependencies to a minimum, and I tend to stay in the Rust end, in which case I don't really need the isolation application, but I still add it because I want this. I want the console logging for when things happen, because this helps me spot whenever an API call is made in the front end. For my purposes, this is often related to when I don't want things to be called. So I can spot things that are currently running in the front end that I might not have spotted or noticed before, and I want to move that to the Rust end. So this helps me keep it more performant, because it'll help me find occasions where I should move it to Rust, as well as what if you have bad code running a lot of API calls to Tauri. Because even though I don't tend to use the JS API, what if I have malicious code that tries to run it, then this can help identify the fact that the IPC is even used at all. So I would recommend all applications to set up this basic isolation pattern. You can literally just copy paste this part and this folder, and you're up and running with what I believe to be best practices for a Tauri application. You'll spot problems, you'll spot performance issues, you spot malware, all kinds of stuff, and you have the ability to extend the security of your application in a simple to use manner. And yeah, that's about all I had to say about the isolation pattern. If you want to read up more on it, if you go to the Tauri website, you have to go to References, Architecture, Inter-Process Communication, and then you'll find it under Isolation Pattern. I'm hoping we'll get it into features at some point, and maybe as the default in people's applications or templates. But currently you find it in References, Tauri Architecture, Inter-Process Communication, Isolation Pattern. And this is all you need to add in order for it to happen. So yeah, that's about all I had to say. Have a good one.